Hello there, and thank you for clicking on this practice set for properties of logs. Please give this video a like if you find it helpful, subscribe to the channel for more math content, and drop a comment or leave a question, and check out the many other videos and playlists we have on the channel. There is tons of stuff to help you wherever you are in your math journey, and if you can't find something, please leave me a comment. Let me know what questions you have and what you would like to see. Without further ado, pause the video to work these problems on your own and then come back to check your work. Okay, so let's get going on this. I might do some of these in more than one way. It depends on what they are or how inspired I feel like being. So looking at this first one, we are going to engage this property here, which says that if you have the log of a product, that is equal to the sum of the logs of the individual factors there. And so this could be split up into log base 2 of 4 plus log base 2 of x. Now, at most introductory levels, this might be as far as you are expected to take it. However, if you are doing this at an honors level or at a pre-cal level, or you have just your algebra teacher wants to push you and stretch you, then you might be expected to go further. And here's what you would be expected to do. You would be expected to notice that 4 was 2 squared. And then you would be expected to engage this piece of knowledge that log base a of a to the x is equal to x. It gets into what does a logarithm do? Well, a logarithm undoes an exponential. So this logarithm of base 2 undoes that base of 2 on the argument, leaving me with just the 2. And so it is 2 plus log base 2 of x. Not all teachers will expect you to do that, or they might not expect you to do it right away on your very first assignment. It might be something that you explore later. So you do what is expected of you for your assignment with your teacher on this particular problem. Second one, we have log base 2 of x to the 4th, y to the 3rd. Now, I mentioned in the video lesson that these are doable in one step. So if I were doing this just for myself, I would say 4 log base 2 of x plus 3 log base 2 of y. And if my students do that, I do not question it. Like, I know this is completely reasonable to expect them to do. However, if this is the first time you have done problems like this, then the work might look something like this. If you are hearing a cat, it is because she is hungry and she's about to jump on my lap or chew the cord to my tablet. Like, I love that. Okay, so the first thing you might do is split up the multiplication into the individual factors. And then once you can see that, you can kind of see where those exponents should wind up, and they would wind up multiplying the logarithms. Okay, moving on. So now we have some division. All right, love me some division. And once again, now I will do these in one step, just kind of show you how we would get there. In the video, I did discuss what like the bases are. So if you don't see a base, the base is assumed to be 10. No, you do not have to write it. Okay, totally okay. So on this one, I would jump right to the answer. I'd say, okay, well, that is 3 log y minus 5 log z. And here's how it would break down in those middle steps. I would look at that division and I would engage this property here, which says that the division came from subtracting some logs. And so this would be log of y to the third minus log of z to the fifth. And then once I do that, I can see, oh, here's where those exponents would go. So 3 log y minus 5 log z. Now, another way you could do that, so I mentioned I might show you some of these other ways. You could use this maneuver and say, well, I know that I can get rid of that fraction by using a negative exponent. 1 over z to the fifth is the same as z to the negative fifth. Well, now I've got a problem similar to the one I had before, where it's multiplication. So this would be log of y to the third plus log of z to the negative fifth. But now when I bring the exponents down, now I'm going to end up getting the negative from the 5. And of course, adding a negative is the same as subtracting. Does it make any difference which way you do those? Absolutely not. And the shortcut way of thinking about it is anything that you see in that denominator, no matter how you want to get it out at the end, it's going to end up subtracted. Anything you see in the numerator is going to end up positive or added in. Number 4. We've got something here, log of 2x to the third over y squared. So again, I can do this in one step. So I'm going to have log of 2 because the 2 is in the numerator. This will be plus 3 log x because x to the third was in the numerator, minus, because the next thing is in the denominator, 2 log y. And no questions asked, you can absolutely do it that way in one step. If you need to, here is the breakdown for the work on that. So we would have splitting it up with the division first. We'd have log of 2x to the third minus log of y squared. Then I might recognize, ooh, right there, that is multiplication. So that'll be log 2 plus log of x to the third. And then we'll just bring that log y squared down. And now I have my spots for my coefficients. So log 2 plus 3 log x minus 2 log y. Up to you. As always, you want to follow your teacher's instructions. Okay, I know I do not like it when my students come in doing stuff wildly different from how I showed them in class and they're like, I found some other video out there. Okay, I don't want to be that person for you and for your teacher. So always follow the directions that your teacher is giving you. And if you like this way better, and it really is a way that makes more sense to you, feel free to share the link for this video with your teacher. And they can leave me a comment or, a question, like that kind of thing. And, we can, find, collaboratively different ways of doing things. All right, so number 4, we have log base 4 of 4x over y to the third, z to the third. Now, this is one that I might not do in one step because I'm looking at log base 4 and then I see the 4 there and it's like, I know something is going to happen with that. I think I'd like to take it one step at a time. So let's split up that division first. So log base 4 of 4x minus log base 4 of y to the third, z to the third. Now, what I want you to pay close attention to here is that this log with the y and the z are both being subtracted. It's the whole thing. Now, it's true that I have multiplication here, but that multiplication is following this subtraction that has happened. It's like this whole unit. So when I go to expand this out, I'm going to have log base 4 of 4, and this is multiplication right here, plus log base 4 of x minus, and I'm going to open up parentheses because I want to retain my grouping. This will be log base 4 of y to the third plus log base 4 z to the third. Okay, and I did that because it was the entire thing with the y's and the z's that was being subtracted, and I want it to continue to be the entire thing with the y's and the z's. Now let's go and distribute that subtraction. Okay, log base 4 of 4 plus log base 4 of x minus log base 4 of y to the third minus log base 4 of z to the third. And last but not least, I am going to move those exponents down front. I got one small dilemma, and that's happening down here at the left. Log base 4 of 4. Well, I know that those undo each other. The question is, what's my exponent? Well, the exponent on that 4 is a 1. That's log base 4 of 4 to the first power. And as we established, log base 4 undoes that base, leaving you with 1. 1 plus log base 4 of x minus 3 log base 4 of y minus 3 log base 4 of z. So those are coming down front. Are there shorter ways to do this? Yes. Can you skip one or more of these steps? Yes. Could you, in theory, do this entire thing in one step? Also, yes, although I might recommend 2 steps at the minimum, but it is doable in 1 step. You certainly do not have to do it in like 4 steps like I did. Okay. So you don't mark yourself wrong if you did it in fewer steps. The important thing is that you can get to the end and you understand what happened to get you there, not how many points. How many steps you show. Now, beginning in number 6, the directions change and the directions become collapse. So this is one where you would write it as a single logarithm. So we are just using the same properties, but in the other direction. And so we'll use this one, which is when you're subtracting the logs, that would be the same as 1 log if you were dividing the arguments. And you might see parentheses around that. I did not do that in the typing because the program made the parentheses look really goofy, and I did not want goofy looking parentheses. But you can do 3 divided by z. All right, now, as before, these are doable in 1 step. So I'm going to do this in 1 step just so you can see how this would look. Okay, so this would be log base 2 of x to the 4th times y to the 3rd. And if you look at it, you might say, all right, I see where all that came from. I see where you got the exponent of 4, where you got the exponent of 3, because those were the coefficients. And you're multiplying because the original expression was adding. Okay, if you were doing this out and you want to show the steps, typically it goes in the reverse order of what we were just doing, where before the last thing that we were taking care of were those exponents. Now it's going to be the first thing that we do is get those coefficients out of there and into the exponents. And now if I have 2 logs that are being added together, that would be the same as multiplying the arguments, parentheses optional. Number 8, 1/3 log base 2 of x. So the problem here is the coefficient, and we have reasoned our way that this is something that would always work. And so you can do a deep dive on that on your own, or if you really want me to go deep into that and like say, okay, I want you to show me that this still works with rational exponents, drop me a comment, let me know that that's a video you would like to see. Now you might be able to leave it like this, or you might need to change it over to log base 2 of the cube root of x. And that uses this piece of information about square roots and rational, not square roots, but roots, radicals, and rational exponents. It might not be a square root. It could be a cube root like this one. So again, follow your teacher's directions on that. Okay, like what is an acceptable form for your answer? Number 9, well, we are just about done. So number 9, we can, again, do this in one step. And what I'm going to say and suggest, if you're with me on this, is if you did not do it in one step, cover up your work and try to do it in one step. Just like try to do these two in one step. Pause the video and just try to do it. See if you're able to do it without doing the middle steps. All right, so here's what it would look like. This as a single logarithm would be log of x to the third, y to the fourth divided by z squared. Anything that's subtracted is eventually going to land in the denominator. Anything that's added is going to remain in the numerator. I'm going to work this one way, showing the scratch work, and I'm going to do number 10 a different way so that you have some tools, some different ways of looking at it. So for this, again, the first step we would typically take is get those coefficients into the exponents. So we'd have log of x to the third plus log of y to the fourth minus log of z squared. When I am adding, that would result in me multiplying the arguments. So x to the third, y to the fourth. And then if I am subtracting, that's going to result in division, where my numerator will be the first argument and my denominator would be the second argument. So there's your middle steps. And last, but certainly not least, is this log base 2 of 2 minus log base 2 of x minus log base 2 of y. Oh gosh. Okay, so there's a couple of ways we can do this. We've got the log base 2 of 2, which is equal to 1. I'm just debating whether or not that is the direction I want to go with this. And I don't think it is, because I don't. Okay. Because I want to show something specific on this, which, well, let's go ahead and do it. Okay. All right. So what I'm going to do here is, let's just start with log base 2 of 2 is 1. And again, that's because base 2 and base 2 cancel each other out, leaving me with a 1. Now, what I'm going to do right here is, instead of dealing with the subtraction, I am going to remember that there is a coefficient of 1 there. And what we are going to do is take the -1 and move it into the exponent. And we're going to do the same here, which is going to mean that we have a positive there, a plus. So we're going to take the negative, I'm going to move the minus sign with it. And if you're a little bit confused there, remember this factoid from somewhere in pre-algebra, that like 1 minus 2 is equal to 1 plus -2. So if I go and move the negative, I am going to have a plus sign there. So this would then become 1 plus log base 2 of x to the -1 plus log base 2 of y to the -1. What that does is it gets rid of the subtraction, so that when I do the collapsing, I am not dealing with multiple divisions. So I've just kind of used what I know about exponents to rewrite this. So combining these together now, instead of like division and instead of having that weird negative out front, I now have multiplication. So this would be 1 plus log base 2 of x to the negative 1, y to the negative 1. And now we can deal with the negative exponents. We know that x to the negative a is 1 over x to the a. Okay, like so. Therefore, this would be 1 plus log base 2. The x and the y both end up in the denominator, and I have a 1 in the numerator, and you do not have to write x to the first, y to the first. That's just not a thing you need to write. And so that is probably our best answer to that, the one out front notwithstanding. Now, there are some other ways you could reason that out. So because you are using this to check your own work, okay, I'm going to segment something over here. You might have landed somewhere like this, log base 2 over x, y. I think I would accept that as a teacher. Okay, so that would be if you did not do log base 2 of 2. And if you had any number there other than a 2, you would have to do that. So if it had been log base 2 of 3 or something, you would have to do it this way. You wouldn't have the option of changing it to the 1, to have the 1 out front. So I think that would also be an okay answer. I would not mark it wrong. And if you've got questions about, like, for your teacher, whether or not they would prefer one way or the other, honestly, bring them this, bring your work, and say, hey, I found a video online and the person did this problem and they did it these 2 different ways. Can you go over these in class and tell us which one you would like? And, you know, bring those kind of questions to your teacher. All right, so that's that. Please don't forget to like and subscribe if this problem set was helpful. It only takes a split second to click those buttons, so please do. Drop me a comment with a suggestion or leave a question, and check out the many other videos and playlists on the channel. I will link one down below so you can see it, and I hope to see you in a future video.